Get CSE 2015 set 3 question. The number of 4-digit numbers having their digits in non-decreasing order from left to right constructed by using the digits belonging to the set 1, 2, 3 is. Now we have to find there are how many possible 4-digit numbers are there which are formed from this set, that is from numbers 1, 2, 3, and where they are having like this, all of these 4-digit numbers are arranged in a way of non-decreasing order, means ascending order. This number will always be less than this number. Now whatever number you are having, A, B, C, D, your A is less than equal to B, B is less than equal to C, C is less than equal to D. This is what we have to find. Now this is special kind of number where what we are doing, we can have multiple. Now if we have placed one over here, we can also place one over here. So this is a combination, this is a kind of selection with repetition. Formula for selection with repetition is n plus r minus 1 combination r, where n is how many categories are there, r is how many things we have to select. Now here there are total 3 categories are there, 3 possible combinations, 3 possible entries are there for our given set, and how many things we have to taken out, we have to form 4-digit numbers, so our r will be 4. If we will place this in the formula, we will get that total possible ways to find out all of these numbers is 3 plus 4 minus 1 combination 4, which is 6 combination 4. So which will come out to be 15. So there are total possible 15 ways are there where you are having 4-digit numbers for set 1 to 3 which are arranged in non-decreasing order. Next question is get CSE 2004 question for 1 marks. In a class of 200 students, the total student is 200 student. The universal set is 200 student. 125 students have taken programming language course. We will make a short form for programming language as P. P is 125. 85 students have taken data structure course. D for data structure, D is 85. 65 students have taken computer organization course. Let's take C for computer organization course as 65. So we have drawn this Venn diagram, and 50 students have taken both P programming language and data structure. So P intersection D is 50. 35 students have taken both programming language and computer organization. P intersection C is 35. 30 students have taken both data structure and computer organization. D intersection C is 30. 15 students have taken all 3 courses. P intersection D intersection C is 15. Now this is the thing we have collected from our question. We have to find how many students have not taken any of the 3 courses. The choices is 15, 20, 25 and 35. Now here what we have to find out, this is a Venn diagram and we have to find out this portion. This portion is how many students are there which are not taken any of these courses, which is of programming language or data structure or computer organization. This is what we have to find. Now this is calculated as a total. Now this is how we will calculate this. This portion will be from total. If we'll just subtract this portion, which is portion of all of this portion is of P union D union C, we will get this none portion. Now P union D union C, from the principle of inclusion and exclusion, the formula will be addition of all of this event, intersection of first event with itself, that is if it will be P plus D plus C minus intersection of two sets, that is P intersection D minus P intersection C minus D intersection C, plus intersection of three terms, that will be P intersection D intersection C. Now if we will put all of this value in this equation, we will get the value that is 175. So there are, this total whole area is of 175 students. So P union D union C is 175. To get the non-students, we just have to perform subtraction of total minus this area, which will be total is 200 students. 200 minus 175 is 25. So this will be the answer for this question. Next question is came in GATE CSE 2020. The number of permutation of characters in lilac so that no character appear in its original position if the two else are indistinguishable is we have to find how many counts are there to keep this kind of characters. So here it's given that we don't have to place any character on its original position, and the next is that you are not separating your L. Both L's are counted as different character, but we are just not making any different kinds of arrangement for different two L's. So the possible ways will be here lilac. If we will keep lilac at this particular place, now L appear here. Now each character will not appear on its original place, so L will never occur at this place, I will never occur at this place, L will not occur at this place, A will not come over here, and C will not come here. If we'll just go with the general formula of permutation, we will get the wrong answer. So what we will do initially, we just find out how many ways are there to keep two L's on different places other than their original places. So there will be three possible ways where you can place the L. This will be, I cannot place L over this particular two position, so I can keep L on these three different places. So I can keep L over here, another L over here. I can keep L over here, another L over here. And the third possibility is that I can keep L over here and L over here. So there are three possibilities where you can keep this two L apart from their original position. Now if I am placing L on this particular position, so next thing is that if you look at this particular place, L cannot appear, okay, no problem. At this place, L is not appearing, okay, but at this place, at this last space, C cannot be placed. So there are remaining total three characters, that is I, A, C. Now among that, wherever you are not having, you can't keep the character, we will first try to solve that, and then we will solve the remaining position. If you cannot keep C over here, so you can keep only A and I will have two possibilities. Two possible character can be placed at this particular position. Now again, if you placed A and I over here, so alternate ways will be to keep how many ways are there to keep the characters. Like if I am placing A over here, I can have possibility I can keep I over here. If I am placing I over here, I can keep A over here. So there will be two possible ways to keep I and A over here. There will be only two characters that I can keep on this place, and the last character which is remaining, that is C. So I can keep C at this particular position. You can place this and this vice versa, but you will get the same chances, that is 1 into 2 into 2 ways are there, means there are four ways in which you can keep your this particular L's. Now next is that when you are having another possibility of having L on the second position and next L on the fifth position, then at this position I cannot keep A, so here I can keep IC, here I can keep CI, means two character can be placed and the character which is remaining, that is of A. So A, for only one choice is there to keep the character, so this will be 2 into 2. And at this particular place where you are having L at the fourth and fifth position, now I cannot be placed over here. So what character can be placed over here, that is A and C. I will be having two chances or two characters, two choices of character can be kept over here. If you'll come here, so we will be having two possibilities of character you can place here, or we can say that two possible character can be placed over here, that is C and A, and the last character which is remain, that is I, you can keep I over here. You can vice versa keep this at this particular position, but still you will get the value, that is 4. So in total there are 4 plus 4 plus 4 ways are there, so it will be 12. Summation of this is 12. So there are 12 possibilities where you are just finding permutation of characters where lilac that are not having their character appearing on its original position is 12. Next question. Find the coefficient of x to the power 12 in the expansion of this particular equation. Now whenever we can solve this by using binomial theorem. Binomial theorem is of kind of a plus b or b plus q raised to n. we can expand. This is summation of r equal to 0 to n ncr e to the power n minus r b to the power r. Now we just have to find this term, but these are this individual terms are again are having some kind of powers, so we don't have to make this term in the terms of power. We have to just simply keep the power of 1 for this particular term, 1 or 0. So what we will do, if we'll take x cube common from all of this term, we will be having x cube into 1 plus x square plus so on whole cube. Then we can say that this is the formula. If we'll see the binomial theorem, then we can get this is the formula for 1 minus x raised to the power minus 1. That is from the Pascal triangle for the first diagonal row, we will get this formula. So this is the formula for that. If we'll expand this x cube, if we'll take out x cube from the bracket of cube, we'll get x raised to 9, 1 minus x raised to minus 3. And in this, if we'll try to expand this, now this term is of in the power of where your individual term is of having only power of 1 or 0. So in this case, what we will do, we will try to expand this and we will get the coefficient of x. We want to get the coefficient of x to the power 12. But here x to the power 9 is already multiplying. So from the power of 12, if we'll subtract 9, we'll get x to the power 3. So in this term, we just have to find out what is the coefficient of x cube. Then that term is the coefficient of your x to the power 12 in this particular equation. So the coefficient of your x cube in this equation is this is the formula for this will give us the formula, that is r equal to 0 to n plus r minus 1 combination r minus 1 raised to r minus x raised to r. So this is the formula for calculation of this equation. Now instead of solving all of this, we just have to place the value of r as 3 and find the terms. So if we'll solve this, we'll get the answer, that is 5 combination 3 into x cube. So the coefficient of x to the power 3 is 5 factorial divided by 3 factorial into 2 factorial, that is 10. So whatever coefficient you are having for this x cube, that will be your answer. So that is 10. Next question is appeared in GATE CSE 2014 set 1. There are 5 bags labeled 1 to 5. All the coins in given bag have the same weight. Some bags have coins of weight 10 gram. Other have coins of weight 11 gram. Means in a bag you can either have same kind of coins whose weight is either 10 gram or 11 gram. I pick 1 to 4, 8, 16 coins respectively from bag 1 to 5. Their total weight comes out to 323 gram. Then the product of the label of the bag having 11 gram coin is. Now the question is that we are having 5 bags. Let's name the bag as bag 1, 2, 3, 4, 5. In each bag we are having the count of coins, the coins whose weight is either 10 gram or 11 gram. In the first bag we are having 1 coin. In the second bag we are having 12 coins. In third we are having 4 coins. In fourth we are having 8 coins. And in the last bag we are having 6 coins. And the total weights from all of these bags, if we'll calculate the total weight, we'll get the answer, that is 323 gram of total weight is there. But we don't know in which particular bag there is all coins of 10 gram or in which particular bag there is a coin of 10 gram. So this is the data. Now what I did, I find all possible ways where I can get the value for this particular bag, like what is 1 into 10 or 11 plus 2 into 10 or 11 plus 4 into 10 or 11. For all of this possibility I have tried one combination and there is only one chance where I am getting the answer, that is 323. That is, if I will keep the value of first bag is having 11 gram, second bag is having 10 gram, third bag is having 11 gram, fourth bag is having all the coins of 11 gram, and last bag is having all 16 coins of 10 gram. So in this case I will get the sum of all of this as a 323 grams. So last thing what we have to do, we have to just find out the product of labels of the bag having 11 gram coin. Now only in this first bag, third bag and the fourth bag we are having 11-gram coins. So what is the bag? What is in that particular bag? This is first, third and fourth. We just have to find the product of these bags. So that will be 1 into 3 into 4. Which is the bag? Which is that particular bag? That is first bag, third bag, fourth bag. The product is 12. Next question is that let xn denote the number of binary strings of length n that contain no consecutive zeros. The value of x5 is. Now we have to find all possible binary numbers or binary strings where we cannot keep zeros consecutively. Now the one digit number where you can one digit possible number is you are having two possibilities 0 and 1. So value of x1 is 2. Two possible digit where you cannot place 0 consecutively, so you are having two possibilities. You can have 0 0 0 1 1 0 1 1 possibilities are there, binary numbers are there, but you can't consider two consecutively, so there will be only three possibilities are there. X2 is 3. Now the general formula for this is xn equal to xn minus 1 plus xn minus 2. So in this way we will find out what is the x3. X3 will be x2 plus x1, which is x2 is 3, x1 is 2, so 3 plus 2 is, which will give us the value that is 5. x4 is x3 plus x2, which is 5 plus 3, which will be 8. x5 will be x4 plus x3, that is 8 plus 5, which will be 13. So this is what we have to find out. So value of x5 will be 13. So this answer is correct. Next question is that let exponent of 11 is prime factorization of the exponent of 11 in prime factorization of 300 factorial. We have to find out what is the exponent of 11 in the prime factorization of this particular number. Now we have to find all numbers in the expansion of 300 factorial which are multiple of 11. This is what we have to find, that is exponent of 11 in the prime factorization. Now if we'll try to expand this particular thing, we will get that number is 300 into 300 into 299 into 298 into so on till 3 into 2 into 1. Now among all of this number in the multiplication, we have to find out how many numbers are there which are divisible by 11, and whatever quotient you are getting, that summation of all of that quotient you just have to find out. So this is what we have to find out. So simply what we will do, we will find out in how many numbers are there which are your prime, which are divisible by 11. So 300 mod 11, that is 27. So 27 numbers are there which are directly divisible by 11 and whose remainder is 1. Now the next thing is that among this number there are some numbers which are divisible by 11 square. So which are divisible by in the power of 11 square. So what we have to do, now this is like a number which are divisible by 11. Now we have to find how many numbers are there which are divisible by 11 square. So the numbers which are divisible by 11 square are 2. So summation of this 2 will be 27 plus 2. These many numbers are divisible by your 11. The exponent of 11 is 29. Next question is that in how many ways can B blue balls and R red balls be distributed in n distinct boxes? Now here n distinct boxes are there. Now this will directly go in the terms of your combination with repetition. In combination with repetition, you are having formula, that is n plus r minus 1 combination r ways are there to select r things from n boxes or n different boxes. So here what we have to find out, we have to select both of this. We have to select blue balls and red balls. So the possibilities will be, how many ways we can select blue balls will be n plus b minus 1 combination b. In how many ways we can select red balls will be n plus r minus 1 combination r. So the product of these two will be your answer. So that product is your this thing, and this is matching to this particular equation. So this is the answer for your given question. Next is that we have to find P and Q are considering to apply for a job. The probability that P applies for the job is 1 by 4. Now probability of P is 1 by 4. The probability that P applies for job given that Q applies for the job is 1 by 2. Now this is probability of P divided by Q. This is kind of conditional probability which is equal to 1 by 2. The probability of that Q applies to job given that P applies for the job is 1 by 3. So this is probability of Q by P is equal to 1 by 3. Then the probability that P does not apply for job given that Q does not apply for job is, we have to find probability of P bar divided by Q bar. So probability of P bar divided by Q bar is what? So we just know, we are just having these three values. So we just know from the conditional probability of P by Q will be probability of P intersection Q divided by probability of Q, and probability of Q by P is probability of in the product of these two, that is probability of Q intersection P divided by probability of P. Now this we know from the formula of conditional probability. So we are having the value for this term, and we are having value of this term. So we don't have the value for this particular term. So what we will do, we will just find out what is the value for this thing first of all, and then we will solve this particular equation. So probability of Q intersection P will be, if we'll keep the values of probability of P, we will get the value of probability of P intersection Q is 1 by 12. Just put this value in this particular equation, we will get the value of probability of Q. So by keeping, we will get the value of probability Q as 1 by 6. Now we have all of these values for this. Now this is probability of P bar divided by Q bar. Now this will be probability of P bar intersection Q bar divided by probability of Q bar. Now this is probability of, if we apply the De Morgan's law, it will be probability of P union Q whole bar, which is equal to 1 minus probability of P union Q. Now probability of P union Q is probability of P plus probability of Q minus probability of P intersection Q. So we just have to keep all of these values, we will get the answer, that is 0.8. If a random variable x has a Poisson distribution with mean 5, then expectation E x plus 2 whole square is equal to what? Now most important thing is that when you're having Poisson distribution, in that case your mean and variance are equal. Now we just have to expand this. Now just don't look at this, how you will expand this. This will be equation, this equation will be expanded as x square plus 2x plus 4, x square plus 2 into 2 into x plus 2 square, that is x square plus 4x plus 4, and just keep E on this expectation on each of this term, you will get, that is expectation of x square plus expectation of 4x plus expectation of 4. In Poisson distribution, we know that mean equal to variance. So variance, formula for variance is expectation of x square minus expectation of x the whole square. So we have the value, that is mean is 5. We know what is mean, that is 5. So this is equal, as these are equal, mean and variance and equal, so this will be 5. So we will expand this expectation of x square minus E of x. Expectation of x is 5, so 5 square is 25. So we will get the value of E of x square, it will be 30. We just have to keep the wherever we are having x square as 30 and wherever we are having x as 5. So we will get the value, that is expectation of x square is 30. Expectation of 4x is 4 into expectation of x, which is 4 into 5 plus, now this is constant term, no x is multiplied, so this will be the same entry, so which is 4. So it will be 30 plus 20 plus 4. So for this whole equation we will get the value, that is 54. Next question is, let R be set of all binary relation on set 1, 2, 3. Suppose a relation is chosen from R at a random. The probability that chosen relation is reflexive. Round off to 3 decimal places we have to find. Means how many total possible ways are there in which we can select the relation, and that relation will be a reflexive. So let's understand the set is given, that is having element 1, 2, 3. You are performing Cartesian product on the same set. The possible ways for Cartesian product is like, what are the all possible elements for this particular major relation will be having this many elements: 1 1 1 2 1 3 2 1 2 2 2 3 and all of this. Your relation is reflexive when you're having in the order pair both the places are same, means you are having all on the first place and second place your number is same. So total possible relation will be the total possible relation will be when you are having that each order pair we are having two choices whether that is present or not present. So as there are only 9 possible ways are there to keep that particular order pair, so 9 possible order pairs are there. This can be present or not present, so this is having two choices: present, not present. Now this order pair can be present or not present, so the choices for this is 2. This can be present or not, this choice is 2. So in the same way we have multiplied, we have find out the total possible relation. So total possible relation are 2 to the power 9. Next is that we have to choose a relation which is reflexive. Now the total number of relation which are reflexive will be, your relation is reflexive when you will have only this terms. When you are having these 3 terms, this term and this term, they should be there. In that case your relation will be reflexive relation. Means for this particular place you will be having only one possibility, that is present. You cannot consider that is absent choice. So here the possibilities for selection of this element is only one. You can have this element or you cannot have, so the possible ways to select that will be present or absent. So you can have present or absent choice. This element will be there, so one possibility is there. This element can be present or not, so we are having two choice for this and this should be there, so only one choice is there. So in total we are having 2 to the power 6 choices for the relation which are reflexive. Probability that chosen relation is reflexive will be your favorable event selection divided by all possible selection, that is sample space probability. So it is total number of relation which are reflexive divided by total number of relation, so which is coming out to be 2 to the power 6 divided by 2 to the power 9, which is equal to 0.125. The cardinality of power set is what? This is the set we have given with. Now set is having 11 element, 0 to 10. They are having 11 element, and probability of power set. In your power set, you are having total 2 to the power this particular elements. So if you are having, we have to calculate what is the power set for A. Your power set for A will be 2 to the power, what is the cardinality of A, which will be 2 to the power 11. So which is coming out to be 2048. So the cardinality of power set will be 2048 elements.